Hi. Right, so on Thursday, you did the experiment, or you watched the experiment of testing different samples and getting their pH, and seeing where they were placed on the pH meter. Now, from looking at your homework, it's kind of annoying. I didn't think that happened in the video, but they didn't seem to tell you what the solution was. They just called it acidic and basic, so that's annoying. So when we do it, we will obviously, like, what I would like to do is a lot of the substances that you tested in the first experiment, we'll do the two experiments in one. So you'll test it, is it an acid or a base, with your litmus paper, and then immediately after test it with universal. So you're figuring out, okay, it's an acid, and then you follow up with your universal indicator paper, and you're like, right, it's pH 2, it's a strong acid. And then next, when you put the litmus paper in, it goes blue, so you've established that it's a base, and then how basic is it? Put in your universal indicator paper. Do you know what I mean? So that's kind of what I would like to do, so that your table kind of first indicates whether it's an acid or a base, and then indicates what type of acid, what type of base. Okay, so it's a bit annoying that all they called it was acidic solution and basic solution, but at least you got the idea of how it works. I hope you had a few minutes to look at the simulation, because it's quite cool, and it shows you how the pH meter works as well. The pH meter, I'd love to obviously be able to do it so that we checked if it was an acid or a base using litmus paper. Then we checked how strong the acid or the base was using universal indicator paper, and then we put in a pH meter. But unfortunately, we only have one pH meter. To be honest, there's no reason to have any more. Really, the paper works just fine. But yeah, I will show you how the pH meter works as well, because if you did look at this animation, there was a pH meter in it. I think I showed you that in the video anyway. Okay, so the next thing we're going to talk about is neutralization. Okay, so the hint is in the word. Okay, neutralization. So this is making something neutral. Okay, so it says here, we've already mentioned that an acid is the chemical opposite to a base. We discussed that. So what about when you mix them? Okay, and essentially what happens when you mix them is, I'd imagine, what you expect to happen, which is that if you mix an acid, say a strong acid that is, so if you mix a strong acid with a base that is as strong, does that make sense? So one is very acidic and one is very basic, and they're both the same level of acidic and basic. You mix them together, what you end up with is a neutral solution. Okay, so it would measure with a pH of 7, like water. Okay, so it says it here. What's actually happening is when you mix an acid and a base, you get a salt and a water. Okay, and both salt and water are neutral. So overall, the solution has now become neutral. Okay, so the one that we normally do, this is yet another experiment, and we normally mix HCl, which is hydrochloric acid. NaOH is sodium hydroxide. So hydrochloric acid, that's your acid. Sodium hydroxide, I think we've talked about in one of the other videos, is a base. And they mix together to make sodium chloride. So this here is a salt, and you know that H2O is water. Okay, so this is the experiment that we're going to do. Neutralization can be done in a very accurate way using an acid-base titration. Okay, so that's what we're going to do, an acid-base titration. Now I have it added here, here to our list of experiments. So like I said, we're going to do 1 and 2 together as one experiment, and then we're going to do the titration separately because there's a bit of work to do in a titration. So let's have a look. Okay, so how do you titrate hydrochloric acid against sodium hydroxide and prepare a sample of sodium chloride? Okay, remember sodium chloride is salt. So it goes through the equipment needed, and it goes through sort of the step-by-step, which we'll talk about. I just want to show you the equipment, okay? So over here, okay, this thing here, this is like quite a large piece of equipment, and it's really quite long, and it's graduated. So this is a 50 centimeter one. or 50 centimeter cubed one. I don't know which ones we have in the lab. And then there's a little tap on it here, okay? So essentially what you do, so you always put the acid in the burette, okay, acid above. So the acid, you can see here, dilute hydrochloric acid, goes in here, okay? So you make sure the tap is closed, so it's not just pouring straight out, and you fill it right up, okay? Normally what happens, because, you know, you're pouring, is that you fill it up a little bit too high, okay? You want it filled exactly at the zero, and a lot of the time you fill it too high, and that's kind of what you're supposed to do. So you fill up the burette, or the, you know, take it easy, don't go mad measuring, and you fill it right up. You will be right up, you'll normally be above the zero mark. So what you do is you open the tap and you very, very slowly let it out until you're bang on the zero. And that's how you get it accurate, okay? As opposed to trying to pour it accurate. That tends to, it's just tricky to pour it accurate. Whereas if you fill it up, now when I say fill it up above the zero, I mean just barely above the zero. And then open up your tap and allow it to go out until it comes down exactly to the zero. Okay, and that's your acid ready to go. So, which one did I just do there? Yeah, so using a funnel, fill the burette to the zero mark with dilute hydrochloric acid. So that's the one we just discussed there. You use a funnel because the burette is very narrow. You pour in, it is hard to pour to zero. So what you do is you pour just above zero, and then you use the tap to allow it to kind of come down and be really, really accurately at zero. Okay, so that's the acid up here. Now over here we have the base. Okay, so we take this here, which is a conical flask. There you go. And you're going to use, this is a pipette and a pipette filler. And so the pipettes, you can get them at different measurements, but this one is a 25 centimeter cube pipette. So there's a little line here. Do you see it? Oh, sorry, I just covered it there. Hang on. There's a little line just there. Okay, and if you, so basically you go over to your pipette filler, or to your sample of sodium hydroxide. You put this end into the sodium hydroxide, and then this pipette filler has like a little roller on the side. So you roll it with your thumb, and as you roll it, it sucks the sodium hydroxide up. So you keep going until it goes to this line. So it comes up this, it fills the bulb, and it goes up to this line, and that's your 25 cm cubed filled with your pipette. You then bring it across, and you use there's a button on the top of the pipette filler, and that's like the empty button. So you press that button down on the top of the pipette filler, and that spits the sodium hydroxide out into the conical flask. So now you have your sample. Okay, so that's step one. Using a pipette filler, measure 25 centimeters cubed of sodium hydroxide into the conical flask. Right, next you have to add some indicator. Okay, so it depends. There's a couple of different indicators you can use. You can use litmus, you can use universal indicator, you can use methyl orange, I think is one that you can use as a couple, okay? I think you might use methyl orange in the video, but anyway, it doesn't matter, right? So when you've put your sodium hydroxide in here, you then add a couple of drops, 4 drops maybe, of indicator, and then you put it down. Now our benches are actually grand in the lab because they're grey in colour, so you'd see a colour change off that. But like the school I used to work in, the benches were like that old wood, kind of really dark, so it was harder to see a colour change. But you basically need to put it on a light coloured background just so you can see the colour change. So you put it down on a tile, like a white tile, or a white piece of paper or something like that. But like I said, I think our benches would probably work fine because they're so light coloured. So then you're set up. So you've got your acid here in your burette, you've got your base down here, plus your indicator. And you are ready to go. So that's step 1, 2, and 3. Okay? So now what you're going to do is you're going to open up the tap here, and you're going to let the acid flow down into the base. Now you need to do this really, really slowly. Okay? And you need to almost, like, it's almost drop-wise you're going to put the acid in. And then you need to pick up this conical flask. So hold it under the tap, but swirl it, okay? So you're constantly mixing the acid with the base. Okay, now you can't obviously take it away and swirl it because this is going to be dropping acid. So the acid needs to drop in and you just pick it up and swirl it around. You'll see the guy do it in the video, and obviously when we're doing it, I'll show you how to do it. But yeah, you allow it to drop in. So slowly and with continuous swirling of the conical flask, add the acid from the burette. And what you're waiting for is the indicator to just change colour. Okay, so if you're using litmus, you're waiting for it to, so you're putting litmus into the base, it will be blue. Okay, so they've obviously used litmus here because that's, litmus turns blue in a base. So you're waiting on it to just start to change colour, that moment where you see the first colour change. Okay, because what you'll find is that it looks like it's only barely gone, and then if you put one more drop in, the whole thing changes, and all of a sudden what you've got is an acid. Do you know what I mean? So you literally want the first indication of a colour change, and then if you swirl it, it'll almost all mix in. Okay, so it's very important that's why you add it dropwise, because the first time you notice the colour change, that's where you stop. Okay, so when you get that colour change, right, you record the amount of acid. So let's say, so we had 50 centimetres cubed of acid up here. So I don't know, let's say it took 22 centimetres cubed for the turn to happen. Okay, you go again, right? So you fill back up your burette with the hydrochloric acid, you get fresh base, fresh indicator, and you put it in under. Now you have a guide, right? You know that it's around 22. So what you do is you lash in the first 20. Just let it go in. Turn the tap right open and let it go in. When you get to 20, then you go really slowly. So you like open the tap, let it drop in, close the tap, swirl it. Open the tap, let it drop in, close the tap, swirl it, and keep going. So what you're hoping is that on this second go, you might be a little bit more accurate. So something like 21.5 centimetres cubed. And then once you've got that done, you average them. Okay, so you take an average of your two readings. Okay, and that, what you've done there is you have used acid in the burette to neutralize the base in the conical flask, and you've done that using a process called titration. Okay, then what you can do if you want to is that you can actually make, so do you remember I said acid and base, when they mix together they make a salt and a water? So you can actually make the salt and water if you want. So it's kind of ruined if you put the indicator in, but if you take the indicator out, so now I don't know if we'll bother with this step, but you can repeat the experiment without using an indicator and add the volume of acid calculated in step 6. So now you know how much acid it takes to neutralize the base. So leave out the indicator and just add whatever the average acid was. Now you know you've neutralized it, even though you don't have the indicator, and you know already because of the calculations you did up here. So what you have then in the flask, without the indicator, so it won't be blue anymore, is salt mixed into water or dissolved into water. Okay, if you place the sample into an evaporating dish and rest the dish on a wire gauze over a Bunsen burner, light the Bunsen and evaporate off the water. So you would have done this as a separation technique in first year, or no, sorry, oh yeah, maybe the end of first year. So basically you take the salt and water mixture from here, put it into evaporating dish, heat it up. What that will do is it will boil off all the water, and what you'll be left with is salt. And then you can weigh or find the mass of the amount of salt that's been produced. Okay, so the last step isn't really necessary. It's not the titration. It's just proving, I suppose, that when you mix acid and base, you produce a salt. And obviously, initially, it will be a liquid, but when you boil it off, you will notice that the salt is left behind. Okay, so I want you to take that down, like you've done so far, and I want you to watch the video of the acid-base titration, just so you can see the techniques and things like that. If he gives you, I watched this a while ago, so I can't remember, but if he gives you any data, take that down. Like if he gives you numbers like this one up here, write them down. If he doesn't, that's fine. We'll do it anyway, okay? But if he does, what we'll do is we'll try to copy what he did and see do we get the same results. So it'd be nice to have a little bit of a reference. Okay, so that is your work for today. So watch the video, please. Take down the experiment, and if he does give results, please take the results down. So obviously you will need to take your notes down first and then go in and do the experiment. Okay, so that's all due for Thursday, isn't it? Yeah, Thursday.